Good morning, everyone. This is Dr. Polaiah, working as a professor in the Department of Information Technology at Aeronautical at Institute of Aeronautical Engineering. So today, actually, I want to say one of the uh, important point, that is the point which is right now everyone had to concentrate based on which we are going to use uh, the complete deliver lecture on representing digital images. Why I says this, and one of the important topic is nothing but representing digital images, in the sense this representing digital images, uh, that means a image which captured by the sensor, nothing but a camera. Sensor is nothing but a camera. That camera, whenever it captured the image, okay, that image now we are going to be keep into the, for the sake of different applications, for the sake of user-friendly process. That means a captured image keeping into the user-friendly process, we had to concentrate towards to represent that image into digital formation, digital image. Why? In the sense, today the complete world is digital world. The complete world is computerized processing dependency applications. That means today, real world applications, real world complete phenomena, complete scenario is depends on, it depends on 100% should be depend on the digital formation. Why? What is the reason? The reason is only one point, that is the accuracy of the process, the accuracy of the complete real-time scenario is depends on 100% accuracy, and also speed. That means the process which we are going to consider in terms of speed is completely depends on number of, what we call that one is towards to represent that digital image in terms of 100 and 100% in not only perfect quality process but also timely process also. So that's what I am saying here is there are the two important points which I shared right now. I also said the 2 points which are very important based for the sake of understanding today delivery lectured, that are, one of the point is the captured image is should be keeping in the digital form. The second point is why we want to keep in the digital form. In the sense, the digital form is completely depends upon the real world application in the form of various quality analysis, various simplicity process. Okay, that's what the depends upon these 2 points. We can say that your image is mostly useful to the computer aided process in any real time application. Let we'll see right now the topic which I will say is as important topic is representing in the digital images. Digital images. Okay. So the digital image, I want to introduce about digital image from the fundamentals of the images only. From the digital image fundamentals only. So far we have discussed about elements of visual perception, image sensing and acquisition, sampling and quantization. Okay, and last but not that today topic which we want to concentrate is representing digital image. So these two are internally connected. So sampling and quantization, without sampling, we cannot convert it into the digital formation of the image. If you after you understand this sampling and quantization, which are we discussed in the earlier class, okay, based on that concept, based on that concept, you wanted to keep into the particularly proof of the concept. Nothing but we want to apply that concept which you learned from the sampling and quantization towards to representing the digital image. So how in sense? So that means you had to do concentrate fundamentals only. Fundamentals are very important. Okay, the basics you should not forget. Okay, so we'll start about this representing digital images. So what do you want understanding about digital images is representing in the digital image is nothing but your completely process of the image and computer system by numericals in the form of binary digits. Digital image is nothing but in the form of digital bits called bits. Okay, here we see the general structure of a digital image. First, it is divided into a matrix of pixels, and then each pixel is represent of a series of bits. An image is usually representation of something, while a digital image is a binary representation of visual data. Visual data. Binary representation of a data. What is the data is here? It is your image data. It is your image. Which is right now keeping into the binary representation. Why? Because your digital image. Because your digital image. So an image is usually representation of something, while a digital image is binary representation of visual data. Okay, so you are seeing my face while I'm delivering such a great lecture. You are completely understanding the moment of my expressions only in the form of digital format. That is the example. That is the example of digital image is a binary representation of visual data. You are seeing me. You are looking at me for various of my expressions, which are understandable for the sake of the about this topic. Okay. So see this. These images can take the form of photographs, okay, graphics, and individual video frames. What do you mean the video frames? What do you mean the video frames? So frame is nothing but set of images. Set of images. You are keeping this. So one frame is nothing but content of certain images. So that means individual video frames, nothing but a video is nothing but a frames. That means set of images which are moving in sequence. That we call as individual video frames. For this purpose, an image is a picture that was created or copied and stored in electronic form. The representation of an image can take many forms. Most of the time, it refers to the way that the conveyed information, such as color, is coded digitally and how this image is stored. That is, how we structured an image file. So you're keeping the image file. So your image file is 100% representing in the form of one format. One format. Okay, so that is here very important. What is important? A image which you are going to be keeping into the format. What for you are keeping format? So that means a image. This is image. This image now you are keeping in the form of either 2D or 3D form. This image right now you are converting into the digital representation. Digital representation. Digital image representation of digital image. So that means this digital image is nothing but here the data is in your conventional way. Your conventional data, visual data of image is here in conventional way, in the sense in the form of matrix format m by n. This m by n of number of rows and columns of the pixels of the image is right now converted into the digital image. How? How can you convert that? How you may be concentrated? In the sense, you are going to be keeping this complete conventional data in terms of bits. In terms of bits. When you say a data is representing in bits, is nothing but digital. is nothing but digital. Let you see that. Let you see that there are the two elements are required to acquire digital images. What are those? First is the physical device that is sensitive to the energy radiated by the object we wish to image. That is sensor. The second one is called digitizer. Is a device for converting the output of the physical sensing device into digital form. So that means your conventional output, physical sensing output of the device is right now converted in the digital. So what do you want to understand from here? Your understanding first point is the physical device that is sensitive to the energy radiated by the object. We used to get your image by the sensor. That is what sensor is here. You can take what we can take this for sensor is nothing but for example is digital camera. What is that? Digital camera. Digital camera. So the digital camera is right now you understand, and keeping this digital camera, keeping your digital camera in the sense digitizer. So digitizer is here a device for converting output physical sensing device into in the form of digital. So you are using digital camera. So obviously your output is 100% accurate. 100% is accurate image you are getting. Accuracy is 100%. So that is what we are concentrating. So that means a sensor from sensor is right now you are getting your required output. Okay, sensor output. This is output. This is sensor. Okay, your input is your visualization. Okay, your sensor is right now keeping into your required target image. Target image. So that image right now is right now digital image. How your image is right now, your visual data is right now converted to or converted into your digital. How you are converting? Because of sensor is here, your sensor is here, digital sensor. So that is the technology which you are using towards to process, that is computer aided process is right now using input to the computer aided process is right now using the sensor. Sensor is an input to the computer aided process. Such a sensor is right now we are considered as one of the digital camera. Digital camera that you have to use for the converting your visual data into your digital image. Okay, but the internal process of the computer, the internal process of the computer aided process is in the form of bits. Is in the form of bits. Number of bits. What do you mean? Understanding number of bits. It means a pixel, a image which is a 2D image, which is 2D image. This is 2D image. This is 2D image. Being it is a 2D image, we are converting it right now in terms of bits. How it is possible? Because we have that formation of processing in the terms of quantization process, sampling and quantization. We have that accurate process. Okay, so we are going to discuss in detail about that in the coming slides also. No need to worry. But point is here, your bits are right now converted from the 2D image into your required format of bits or in the form of pixels. You can able to find out the pixels at the 2D level. When you are converted into digital form, you're going to find out the bits. How it is possible? What is that reason? Let you see that first of all here. Let you see here. You captured a grayscale image process. See here, you are using your two of the image formats of visual data process. What is the first one is black and white. First one is black and white image, a single color plane with 2 bits. What do you mean 2 bits? 2 bits are 0 or 1. Consider 0 as black, consider 1 is a white. That is depends upon your assume, vice versa. So 2 bits right now you are considered under the single color. What do you mean single color? Black and white. No different colors. Okay, if you consider that single color extended lay in the form of grayscale image is playing with the 8 bits. That means n equal to 8. What do you mean n? This is the n which help us you to understand number of bits in your total image. 2 power of n, that is 2 power of 8 is equal to 256 bits. That is, this varies will be vary 0 to 255. These are nothing. This is the number which these are the numbers are varies in terms of pixel variations. From 0 to position to 255 pixels are vary. We are going to see all the rows and columns wise your detailed information. Okay, your detailed information. So what are this grayscale image right now? We have to concentrate on representation of digital format from the grayscale image format. What are the formats we have? Ready-made format, TIFF, JPEG, BMP, etc. We have different format of digital image. Today, I may be saying regularly usage of format is JPEG format. But today, that programming which we are using in the computer-aided process, the format of digital image is not be fixed with one format. It's not fixed with JPEG alone. Depends upon the system configuration, your computer system configuration, your mini system computer process configuration based, your format of the image may be changed. That is that thing process knows by the technocraft. Technically, how it is processed is known by the technocraft. So that means this only format is not fixed. It may be changes. But point is here, how it is changing, what is the reason to change? We want to understand detail. Let you see the third one and fourth one and fifth one. Third point is color image. 3 colors planes. Each with the 8 bits in the sense maximum number of bits. Normal image will be 8 bits only. The process which is right now up to right now, the technology is up to right now developed for simplicity understanding is 8-bit process, 8-bit image processor. So that means RGB, CMY, IYQ, etc. So RGB is normalization process. RGB is red, gray, black. You are going to use that complete RGB colors. Okay, you are going to use these colors of 3 colors. 3 colors we are going to use in terms of your required format. Converting R is a C, G is a M, and B is a Y. We are going to discuss in detail about this in the coming classes. In coming classes or in the coming slides also will help us to understand in detail. Okay. So next, coming to the fourth point is, which is we want to understand the color image single plane that indexes a color table. So what is the color table? Also, let me to introduce that color table with the coming slide. Understand? So coming to the fifth one is, your images are right now in digital form. What is yours? Only the best image process, best application is compressed images process. For example, a four gray levels image now converted into small image, compressed into 2 gray levels. What happened? Maybe your visualization of the image may 100% different from 4 gray levels to 2 gray levels of the image. Let you see that. So a digital image representation in 3-bit. What do you mean 3-bit? 2 power of 3 is equal to 8. So 0 to 7. Your variation of 0 to 7. For example, your digital image data is here. Your bits are here. Your 0 to 7 is varying. What is the 0 to 7? What is the 0 in the 3-bit process? 3-bit. This one is 3-bit. Okay, 3-bit means 3 zeros. So you want a variation 1. What is the 1? 1. What is the 7? What is the 7? 111. So what is the variation is here? What is the variation is here? So that variation of the digital format, conversion from a conventional value of the image to digital is in terms of in the form of bits. So that representation is here. So your n value is 3 bits, which is here quantization. So that means you are converting your grayscale level of the image 2 power of n is 2 power of n is nothing but 3, that is 8 bit. 8 bit is nothing but 0 to 7. How it is varies? This is the image. This is the image data. These are the data. But this data is right now in bits. How many bits are variation? The combination of the variation of number of bits are here 3. 3 how it is varies 3 bits from 0 to 7. So 0 is here. Why it is here? Why can't here? Because you are selected, your captured image by the sensor have the data, it not be in the sequence. It may be various. So that's what this complete image data is right now in digital, nothing but bits. That's what we can understand from this slide. Okay. So coming to the other slide, which I wanted to help you in detail to understand. Image is here. Image is here. This 2D image. Basically, 2D image we are taking. 2D image is right now in a grayscale. What do you mean grayscale? Black and white. Now converted into digital. This is digital. This is digital image. What do you mean digital image? Completely number of bits. With previous slide example, I have taken my image is grayscale images right now keeping in the form of grayscale images right now keeping in the form of n equal to 3 bits. 3 bits. That means my grayscale images here is number of rows and number of columns is maximum 8. That why it is 8? 2 power of why it is 8? 2 power of n is equal to 8. Why? Because n equal to 3. N equal to 8. So what is the here? So m by n value will be 8. So the maximum pixels values in rows and columns are varies are 8 combinations, 8 bits combination. So that means your image right now, this value is right now converted into number of bits, that is 0 to 7. So I said here how this 0 to 7 varies. You are going to be follow with one of the lookup table. So what is the lookup table is here? This is your sensor image data. This is your sensor image data, which is varying in between 0 to 7, which is we have to understand from here. And now converted into digital representation, that is bits. 0 is representing it 000. Why you keeping only 3 zeros? Why not 4 or 5 something? Because your grayscale is your assumed, your captured sensor image is your assumed as a 3-bit grayscale. So 3 bits combination will be 3 zeros. So it's all varies from 0 to all are 1. 0 are the null, no value of the pixel value. Intensity of the pixel is 0. But 111 is maximum pixel value of the intensity is maximum. So these variations are varies. These are the which we are understanding from the previous slide. Now let us you capture the image with the first and the foremost important process which we are understanding in terms of computer-aided process. You are captured your image is right now color image. Color image is nothing but RGB colors. Okay. So your color image quantization example is 24 bits RGB image. That too, your captured image is right now, which is your understanding, complete one image which is here, a cat or a mat or whatever maybe, or a dog, whatever maybe, your captured image. This image is right now in color image. Color image. What is the meaning of color image? Your understanding is here your red color R, your blue color is blue, RGB, green, RGB, blue. What do you mean RGB? Red, green, blue. RGB. This is RGB. So your number of bits are 24. 24. Your maximum variation is the number of bits of the combinations are various, or maximum 24 bits of the image. What is this 24th bit you are capturing is here. In your image is varying 0 to 255. Let us also 0 to 255. You are capturing image in between 0 to 255. You are capturing image is only one value, that is 24th bit. What is its 24th bit you are understanding? You are understanding that some part of the image we are going to be check, analyze, understanding how your sensor is working. So that means one sensor of the bit we are going to be, one sensor bit of the value you are going to be help towards to evaluate. So while you are evaluating, you are understanding your written programming in the form of digital format is working or not. Or your sensor which is captured of your RGB image, RGB means red, green, blue image is right now how it is changes. How these colors are changes. Sensor is right now your color image, your digital camera. Your sensor is right now digital camera. Nothing but color image will capture. So that value you are going to find. So you can understand 24-bit image. I said here it is varying in between 0 to 255. What is the 0 to 55? In between 0 to 255, 128 will be there, 135 will be there, 164 will be there, 166 will be there, 138 will be there, like that. But you colored, you captured image, your image is digital image. Your image is right now digital image. You have captured. That captured image, you are divided into 3 parts according to your required colors. Red, green, blue. And according to this red colored part are keeping into the red part of the pixels. So position, pixel value, position in between 0 to 255. And you have green values you are keeping in order of low to high, which are varying from lower value 135, and according to these rows and columns we are keeping. Understanding? This is the one column you are directly keeping here. This is another column keeping here. So that columns and rows we are arranged. And next goes to blue. Here one column you are keeping, another column. So rows and columns we are achieved. So what do you mean to understand here? You are understanding this. You are understanding this blue color values are help us to understand the digital bit variations. The color planes are various. For example, let us see, this is your captured sensor image. Now converted into your required pixels on the screen. I taken the best example is 24 bits associated with each pixel in the frame buffer are split into the 3-bit groups, 3 8-bit groups to specify the pixels in terms of red, green, and blue RGB components. Red, blue, green, okay. So your red color is right now converted into green and then blue. So 8-bit color. What do you mean to understand here is Digital to analog conversion is here. Again, the digital to analog conversion is here. What do you want to do on a digital to analog conversion in the sense? You want to see the visual data in the form of real time, understandable. Real time application point of view, understandable. So that's what you are taking the digital to analog converts. There are the different types of converters. One is digital to analog converters. Another one is analog to digital converters. So under this digital to analog converters, again there are different types. Again you have to understand which you are concentrated on towards to preparation of some IC packages, IC values, IC, that is integrated circuit constructions. So based on that, you are using your chip is here DAC chip. It is digital. Input of this to this chip is digital. These are digital. What do you mean digital? Digital means bits. What are the bits? Zeros and ones. So you are going to be get your 24-bit true color images here. So you can understand from this graphical representation of digital representing of digital images. Red is red, blue is green is green, blue is blue. So red, green, blue are how it are representing in the form of understandable from digital images. How? In terms of accuracy. That is what only. Why we are depending on computer-aided processing in the sense you are in supposed to be understand each and every part of the pixel values from the captured image, from the normal digital captured image is right now converted into digital form in the sense we are going to be able to understand each and every part of the pixel, whether that image is not in the visible data. What is the reason? Whether that image is, if not in the visible data, then what is the reason? That reason you wanted to evaluate, that reason you want to find out or determine only depends upon the in easy process which we are right now applying the representing in digital images. We are concentrating that. Okay. So you can understand here is, for example, I'm written here one of the simulation program by using MATLAB. Okay, so I captured the images here, and that captured image colors are how it is varies in terms of RGB. With RGB effect, again there are minor changes of the colors. How those are minor changes of the colors will be, that means not be 100% red color. It may be changes some other values. Okay, so how in this sense those varies in terms of required frequency formation movements. So for example, this is red color, pure red color. This is complete red color. The image which I am taking example is understanding how this RGB are varying, how RGB are varies. The colors are how various. Depends upon your brightness, contrast, saturations, color rotations, and perspectives, and the scale which you are arranging in terms of 3D, 3D format in the view of your image. Okay, you understood, I think so. So coming to that values are various which we are want to understand in detail of pixel intensities values. We are going to use one of the determination of the pixel intensity values of the method, one of the method which we are using towards to finding the pixel intensity values. Okay, that method is called histogram. So we are going to be use histogram in terms of color histogram. Color in why color image which is right now you are taking not grayscale. It is not grayscale image. It is color image. It is not grayscale. It is color image. Color image. It is color image. So color image we are applying the color histogram. Why we are going to be understand why with the x-axis values are varying. Okay, each and every pixel values how it is varies. This is red color of the pixel variation. It is a green. It is the green color. It is a blue color. How these variations? What are the percentage? In between 0 to 55 pixels are here, and your intensity of the pixel is here, y-axis, and y-axis versus x-axis values are various. You are finding different values. Mean or red color mean how much red color you have in the image, how much green color you have in the image, how much blue color you have in the image. You are finding it as an average values. So for that we are using one of the best method which are uses for the determination of pixel intensity in the color. So that image which you are taking, okay, this image right now converted to digital image in the sense we are going to be used in your required format. For example, your black and white image, now you are converted into your color. Your color image right now converted into your required format. What do you mean required format is computer process. Computer aided process. So this computer aided process means one is image is right now you are representing either black and white or color image. That color image you are keeping in the required format. Why you want to concentrate required format in this sense? Your computer aided process needs that required format. That simply we say in one of the very important point in digital image processing, pre-processing of the image. Pre-processing is nothing but required for keeping in required format. So, right, image formats which we are going to be understood right now in terms of structures. Small surface structures, either natural or artificial, regular or irregular. The structure examples are hood box, knitting patterns. Statistical structures analysis describes structures as a whole based on specific attributes which we are had to concentrate here: regularity, coordinates, orientation, contrast, etc. So you are required structures you can keep your images. Okay. So that means let us see here structures which we are going to be format keeping in the format. That's what today everyone while you are understanding this video lecture, you have to concentrate that the world is right now we are going to use different colors for the sake of home appliances, for the sake of home constructions, for the sake of even any type of system is running right now. Any type of system is a traffic control system is right now 100% depends upon the colors only. You know that there are the four colors they are using: red, green, blue, yellow. What do you mean that? These are the colors which they are going to be keeping to control, keeping in terms of controlling process. Even the train control process also. So keep in your mind, we should not neglect while you are understanding this type of concepts, we have to apply into immediately which are we are feel some of the difficulties in our lifetime, some of the difficulties in our day-to-day life that we can solve by using these concepts. So what is that concept? Your color image now keeping into the your required structures. Take this structure. How you are going to keep? What are these? I said here controlling, traffic controlling process. What is this? It's all very important. That's what I'm saying is you have to remember how these digital images are represent towards to your societable applications. Let you see that. What are those types of images? There are three types of images. There that are binary image. If it is binary image, simple type of image, it takes only two values. What are those values? Black and white. Black and white are nothing but 0 or 1. Black and white image means keeping in digital format, in the sense 0 and 1. So black and white and 0 and 1 are using respectively. So the binary image consists of 1 bit. First 1 bit image. It takes only binary digital representation, a pixel. Binary images are mostly used for general shape or outline. The best example of binary image representing in the general shape or outline, in the sense optical character recognition, that is OCR. So coming to the secondly, we are going to be use these binary images are generated using threshold operation. Okay, threshold operation I'm going to be explaining you in the coming class. Okay, so when a pixel is above the threshold value, then it is turned white color. One, the which are below the threshold value, then that are turned black. What do you mean this threshold value? This is the knowledge of the image processing based. You are arranged one particular value is threshold value. It's a scalar value. That value will help us to keep your image either in the purely completely in terms of black or completely in white in terms of digital formats. So after an image has been segmented into the object and background regions, one intends to represent the described them in characteristic features for computer processing. During pattern recognition or in quantitative codes for efficient storage during image compression. Efficient storage during image compression. Why image compression? Why we want to understand here the digital representation, the representing of digital images, especially we are concentrating on at the time of compression, in the sense because one mobile to the other mobile, one system to the other system, you want to send the image, you cannot send because their configuration, their specification of their usage of mobile or usage of that personal computer may be different. That's what a user can think that keeping an image in a standard format. That means the image which is not in standard format may be used in keeping in the compression. Once you have compressed the image, okay, automatically your image compression may be used to send any devices. So that image compression is right now one system specification, one system specification to the other system. This is unknown specification. You are sending or transform. While you are transformed to the one system to the other, you are going to keep in terms of image compression. That means your image, for example, you are applying some application process with your photo. The photo which you are captured with sensor, digital sensor, may not be shootable with their system specification. That's what you may be captured in terms of 3 bits, but they need only 2 bits image. But they need only but they need only 2 bits. How? So you are going to make the calculation. That's what we can use this. So finally, I wanted to complete this lecture, okay, with the help of the references which I use it for the discussion of this complete image processing in terms of in terms of representation of digital images. First book, maybe you compare with the second book, but you can refer both also. Okay. So I'm very thankful for your patience, for the understanding of this complete knowledge concepts. Okay. we'll see in the coming class some more concepts which are related to or which are based on using of this delivered concept towards to other concepts. Okay. Thank you so much. Thank you. I'm stopping here. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.